Hello, everybody, and welcome to Friday. Today we are continuing to learn about functions and modeling and predicting change. And this time we'll be looking at it through the perspective of a scatter plot. And a scatter plot is just like a function in the sense that it does model and can be used to predict change in this data set. Because we know that by definition of a scatter plot that in real life the points don't always lie on a straight line. So a scatter plot relates those two sets of data, which can be used to investigate the relationship of the two quantities. So we see here that as my temperature changes, the sales change with it. Okay, so a scatter plot does model and predict change. Now, one of the things that we can use to help us in modeling and predicting change from a data set is what we call the line of best fit. And so what the line of best fit is, by definition, is that if the pattern of the scatter plot is linear, you can draw a line to summarize the data and predict data not represented on the graph. So as you see here, we have a graph that is showing as your salary increases, your car price, or the price of the car you're able to purchase, increases as well. So we can draw that conclusion based upon the fact this is a positive correlation. As one increases, the other increases as well. But since we draw the line of best fit in, we can actually predict what a person who has a salary of $150,000 might purchase for their car, and what somebody who, say, makes $100,000 might purchase for their car as well. So that's where a line of best fit comes in to help with modeling and predicting change. Now, one thing we want to consider today is how closely aligned is the data. So this is a way to give more meaning to positive and negative correlations and whether they're weak or whether they're strong. And to do this, we use what we call the correlation coefficient. Now, this here is a very long formula that is used to find the correlation coefficient. And for those of you that might be joining me in January at Southern, we can certainly do this long formula in class if you would like, or we can just do it the simple way and use Desmos, okay? So the thing is with using Desmos is that this is already something you have been doing. All right. If you think back and remember back to when we did this project on consolidating the school, okay, the school consolidation project, you took a table of values and you entered this table of values into Desmos. And then you used Desmos to find the equation of a line. And then you use that equation of the line to predict change. What you actually were doing here is this was a scatter plot. And this here was the equation for the line of best fit. So you used that scatter plot, the data, and the equation of the line of best fit to model and predict change for year 5. All right, so you've already been doing this, which makes this lesson rather easy for you today. So if you look at this table here, this was the table that we just saw over here, entered into Desmos. And when you would enter it into Desmos, you see these 3 values here at the bottom. M was your slope. B was your y-intercept. Okay, so here's our slope. Here's our y-intercept. And here is what we call the correlation coefficient, which is R. And so that big long formula that you saw on the previous slide, Desmos is programmed to compute that R value for you. And this is what it looks like and where it appears. Okay, we are not going to get too much into R squared in Math 1. All you have to really know about R squared is this is actually a percentage. And what this would mean is 84% of our data is closely aligned. And that's all that means. You'll learn more about that in statistics in high school. But what we're going to be concerned about here in Math 1 is just simply this correlation coefficient and what the value of R is. So what we do is we see here that the value of R is a negative 0.9177. And what we're trying to say here is the correlation coefficient answers the question, how closely aligned is the data? So if it's a negative decimal, it's a negative correlation. So like you saw on the previous slide, it was a negative, so it's a negative correlation. Obviously, a positive decimal is going to be a positive correlation. Now, we know that it is a strong correlation if it's close to 1 or negative 1. So if you look down here on our scale, the correlation for the previous was a negative 0.9177. So if you look here on your scale, 0.91 is very close to the negative 1. So that means you have a strong negative correlation for that particular data set. All right. If your data set had a R value of a positive 0.917, then it would be over here on the strong positive side of the scale. So as you can see, this scale with that R value can be used to determine if you have a weak correlation, if you have a straight positive or negative correlation, or if it's a strong correlation, all by where that R value falls on the scale. All right, so let's look at an example here. We see here that the weekly boat sales for Dustin's Marina are given in the following table. So using Desmos, we're going to construct a scatter plot and line of best fit, then identify the correlation coefficient and state if the correlation is positive, strong positive, negative, or a strong negative correlation. All right, so we go to Desmos, and just like we did before, we hit the plus key and come down to table, and we're simply going to enter in all the values. All right, and so you can already see over here how your points have been plotted. So there's your scatter plot over there on the graph. Now we're going to hit the plus key again, and we're going to type in the expression. So remember, the expression is y1, and then the tilde, which is the approximately symbol, is the shift, and then you go up to your upper left-hand side of your keyboard. Under the ESC key, if you press shift, you see the tilde up there. So y1 is approximately mx1 plus b. All right. So notice the data it gives you down here. It gives you the m, which is your slope or your rate of change, the b, which is your y-intercept, and then here is your r factor, which is 0.8723. So if we take that r factor and apply it to our scale over here, I see that it's going to be a strong positive correlation. All right. So what we will just do is we'll just take and we're going to screenshot this. And there we go. And then for type of correlation, I'm just going to type right down here. Strong positive. All right. So that's for the first one. So you see, you can look at your line of best fit, and you can see that your data is pretty close to your line of best fit at the same time. But your R factor, your R correlation coefficient, gives you a numerical representation of it as well. All right. So let's go to the next one. It says the table shows the number of new members to join the outdoor club. And we're going to do the same thing. Use Desmos to construct a scatter plot and line of best fit. Identify the correlation coefficient and state if it's positive, negative, or strong negative. All right. So easy way to do this is if you leave everything set as it is, and some of you may have already figured this out when you used Desmos before. We'll just take these values out because I'm still doing 1, 2, 3, 4, 5, 6. And then I'll just come up here and change that to 3, 6, 4, 3, 6, 4. All right, so I get something that looks like this. And notice when you look here, again, you have your slope, which is m, your y-intercept, which is the b value. But now my r factor here, my correlation coefficient, is 0.1565. Okay? So again, if I were just to apply that to the scale, that's going to be over here, almost close to 0. So the closer we get to 0, which means we're getting to a weak correlation. Okay, so same thing. I'm going to screenshot this. And come over here, put it on my slide. And then for my type of correlation, this is going to be a weak positive correlation. And I'm basing that not only just on how it looks, that the data is not close to my line of best fit, but also based on where that correlation coefficient falls on the scale, that it's closer to 0. So because that is closer to 0 at 0.1565, I'm going to say that is a weak positive correlation. All right, so let's look at the next one. It says here the table shows the resale value of 6 SUVs plotted against the age of the vehicle. Using Desmos, construct a scatter plot and line of best fit. Identify the correlation coefficient, and again, state if the correlation is positive, strong positive, weak positive, negative, or a strong negative, or a weak negative. All right, so let's go back to Desmos again. And again, I have 1, 2, 3, 4, 5, and 6. So I'm just simply going to come over here and change these values. All right, so there's my scatter plot, and there's my line of best fit. And again, if I look at my parameters, my slope is a -2. My b value, my y-intercept, is 26. But notice here that my correlation coefficient, which is r, is a -0.993. So again, if I apply that to the scale, a -0.993, that's going to be a strong negative correlation because it's way over to this side of the scale. Okay, so again, I'll come over here and screenshot all of this. And I've got a strong negative. All right, so this is what you're going to be doing for today. There's 8 more slides for you to do. And basically, you're going to do the same thing that I just did, is use Desmos and construct your scatter plot in your line of best fit. And then do the screenshot of the graph next to the table, and then state what type of a correlation it is down below. Okay, so what you submit to me should look like the 3 examples that I already did for you. Okay, so If you have any questions, I will be on Google Meet during my normal time. You can also email me if you have any questions as well. And just click the blue submit button when you're done with this, since it's an embed, and it will come directly to me. Have a wonderful weekend, everybody. And I look forward to having another lesson for you on Monday.